All right, welcome to the examples video. We're going to get started because we've got a lot to get through. First thing I'm going to say, you're going to need like a super duper amount of space because these are pretty long. So find the slope of the tangent line to the function at the given point. Now, slope of the tangent line, lost my pen there, we go. That is the same as finding the derivative. So remember, that's when what we're doing is the limit as h approaches 0 of f of x plus h minus f of x over h. So if I'm going to do that, I'm looking at taking the derivative of this function. So that becomes the limit as h approaches 0 of 2 times x plus h squared minus x plus h minus the original function, 2x squared minus x, all over h. Now multiplying this out and this out, I get 2x squared plus 4xh plus h squared minus x minus h minus 2x squared plus x all over h. And my x over x cancels and my 2x squared over 2x squared cancels. Looking at what's left in this numerator, I can take an h out. So I get 4x plus h minus 1 over h, and those cancel. So this becomes, and remember I'm taking the limit still of this, the limit as h approaches 0 of 4x plus h minus 1. And now if I evaluate this at 0, I get 4x minus 1. That tells me that the derivative function is 4x minus 1. So the derivative function, again, this is a function that I can use to find the slope of this parabola at any given point. And now I want to find the slope at x being negative 2. This 10 is not particularly relevant for this question. It could be relevant in other questions, and you'll see that, but it's not in this case because all I need is x. So I want f prime of negative 2, which is 4 times negative 2 minus 1. So I get f prime of negative 2 is equal to negative 9. And that's how I should write that final answer. And again, what I just found out is the slope at this point on the parabola is negative 9, just at that instant. All right, so looking at another example. I have the limit as h approaches 0 of 1 over x plus h minus 1 over x all over h. So I'm going to have to get a common denominator in this numerator. So this will become x over x plus h minus x plus h times x. So I multiplied by x over here, multiplied by x plus h over here, and then wrote it as one denominator, one fraction. This is all over h. Distribute that negative, so it becomes x minus h over x plus h, and that didn't write. Let's give it a second. And let's see. There we go, x times x plus h. So my x minus x cancels. This is all still over h, and now my h over h will cancel. So this becomes the limit as h approaches 0 of negative 1 over x times x plus h. Now if I evaluate this at h being 0, that gives me negative 1 over x squared. This again is my derivative function. I want to know, though, what is the derivative at x being 3, or what is the slope of a tangent line, same thing as the derivative, at x being positive 3, sorry. So that gives me negative 1 over 3 squared. So f prime of 3 is equal to negative 1/9. So again, what I just found out is that the slope of this function, this weird looking function, at 3, 1/3, the slope at that point would be negative 1/9. All right, another example. Definitely a more longer example. I want the limit as h approaches 0 of square root x plus h plus 1 minus square root x plus 1 over h. So got to, again, use some of our 11.2 skills here. I need to solve this by rationalizing. So I multiply by the conjugate, square root x plus h plus 1 plus square root x plus 1 over square root x plus h plus 1 plus square root x plus 1. That gives me x plus h plus 1 minus x plus 1 over h times square root x plus h plus 1 plus square root x plus 1. So distributing this negative, I'd have x minus x, 1 minus 1. So I have h over h square root x plus h plus 1 plus square root x plus 1. My h over h can cancel. So again, I still want the limit as h goes to 0 of a 1 over square root x plus h plus 1 plus square root x plus 1. And now I can evaluate this at h being 0. If I substitute that in, I get 1 over 2 square root x plus 1, which is what the derivative function is equal to. Again, this derivative function is giving me the slope of the tangent line at any given point, or the derivative at any given point. This is an x plus 1. I'm looking for the derivative at x being 3. So f prime of 8, sorry, x being 8. So f prime of 8 of 1 over 2 square root 8 plus 1, which gives me 1 over 2 times square root 9, which is 1 over 2 times 3. So the derivative at that point is 1/6, which is again giving me the slope of the tangent line. All right, moving along, find the derivative of, and I just have 3 more. Now, something to keep in mind here, in these questions, I was asked to find the slope of a tangent line at a given point. And the fact that it was at a given point meant that I was getting a numerical slope, -9, -1/9, 1/6. Now I'm being asked to find the derivative, but it's not at a specific point. So I'm looking for an actual function, a whole function, which actually means that this is like less work because I don't have to do the extra part of substituting in. These are also going to be a ton of space. So the limit as h approaches 0 of -4 times x plus h squared plus 6 times x plus h minus 2 minus the original function, -4x squared plus 6x minus 2 all over h. I told you these will come back with a vengeance. I wasn't lying. Now I'm going to FOIL this out and multiply it by 4 and distribute this 6. So it becomes the limit as h approaches 0 of -4x squared minus 8xh minus 4h squared plus 6x plus 6h minus 2 plus 4x squared minus 6x plus 2 all over h. My -4x squared, positive 4x squared. My -2, positive 2. My -6x, positive 6x. And now I can factor h out of the numerator. So I get limit as h goes to 0 of h times -8x minus 4h plus 6 over h, and my h's cancel. So the limit as h approaches 0 of -8x minus 4h plus 6. If I substitute that 0 in, if I'm evaluating this limit now, I get -8x plus 6, which is the derivative. So there, done with that part. Now, again, I'm not asking the derivative at a specific point or the slope of a tangent line at a specific point. So this is done, just -8x plus 6. Whew, we're going to get through this. F of x equals -1 over x minus 3. So I want the limit as h approaches 0 of -1 over x plus h minus 3 minus -1 over x minus 3 all over h. Again, I'm going to have to get a common denominator here. So I'm going to multiply by x plus h minus 3, and I'm going to multiply by x minus 3. I'm also going to recognize that this minus negative would just become one big positive. So this will become -x minus 3 plus x plus h minus 3 over x plus h minus 3 times x minus 3. Waiting for my x to show up here. There we go. Got a whole bunch there. All over h. So my negative x plus x would cancel. My negative 3 minus 3 would cancel. So I'm left with just the limit as h approaches 0 of h over x plus h minus 3, x minus 3, all over h. Now those h's cancel. So this becomes the limit as h approaches 0 of 1 over x plus h minus 3 times x minus 3, which becomes 1 over x minus 3 squared, which again is our derivative function. And again, when I evaluated this, I said, okay, h is 0, so I have x minus 3 times x minus 3, which gives me x minus 3 squared. All right, this last one, I mean, if you didn't use a lot of space for these other ones, good work, because this last one is going to cost you all your space. So I hope you've been saving. All right, so we've got 1 over square root 2x minus 3. So I'm going to start this down here. The limit as h goes to 0 of 1 over the square root of 2x plus h minus 3 minus 1 over the square root of 2x minus 3 over h. Okay, so now that I have that written down, I'm just going to come use all my space over here. When I'm looking at this, the first thing I'm thinking is I need to get a common denominator so I can combine these fractions. So I will multiply by square root 2x plus h minus 3 and square root 2x minus 3. So that gives me square root 2x minus 3 minus square root 2x plus h minus 3 over square root 2x plus h minus 3 times square root 2x minus 3, all over h. Now, looking at this, you might notice that it doesn't cancel. Yikes. So unfortunately, what that means is we have to multiply by the conjugate so that we can rationalize some of this so that we can get an h. So we're going to multiply by square root 2x minus 3 plus the square root of 2x plus h minus 3 over square root 2x minus 3 plus square root 2x plus h minus 3. Now, when I multiply that, square root 2x minus 3 times square root 2x minus 3 is going to give me 2x minus 3. A positive and a negative of these is just going to give me a negative 2x plus h minus 3. And this is all over, and this is where it gets really messy, square root 2x plus h minus 3 times square root 2x minus 3 times the sum of square root 2x minus 3 plus the square root of 2x plus h minus 3. Yeah, by the way, this is all over h. So now if I distribute out in this numerator, I get 2x minus 3 minus 2x minus 2h plus 6. Oh, sorry, plus 3. And you can see my 2x minus 2x, my minus 3 and positive 3, and my h over h cancel. So what am I left with? Well, in that numerator, all I have left is a negative 2. So to give us some more space here, I now want the limit as h goes to 0 of negative 2 over the square root of 2x plus h minus 3 times the square root of 2x minus 3 times the square root of 2x minus 3 plus the square root of 2x plus h minus 3. So now if I substitute 0 in, I'm actually going to show it this time because what you get is sort of interesting. I get negative 2 over square root 2x minus 3 times square root 2x minus 3 times square root 2x minus 3 plus square root 2x minus 3. Which, when I simplify this, square root 2x minus 3 times square root 2x minus 3 is just 2x minus 3. And when I add those, I get 2 square root 2x minus 3. So now my 2 over 2 can cancel, and I'm left with negative 1 over 2x minus 3 square root 2x minus 3. If I want to multiply this into the square root, you have to be thinking like originally, if I took it out of the square root, I square rooted it. So to put it back in, I must square it. So this becomes negative 1 over, and I'm going to write this a little bit weird, we have 2x minus 3. And if I want to bring these 2x minus 3's into the radical, I have to square them. And now if I have 2x minus 3 times 2x minus 3 squared, that becomes the square root of 2x minus 3 cubed. And there is my derivative function. So negative 1 over the square root of 2x minus 3 cubed. So there is like some really awesome simplification there. What I have here in purple, not exactly your typical question. You know, don't get overly concerned for that for pre-calc, but for calc, I mean, yeah, it's pretty normal. All right, so just one last slide. 2 questions. Find the slope of the tangent line at a given point. So find the slope of the tangent line means find the derivative. And write the equation of that line. So in this case, I am going to be using that whole point. So I'm going to start with just finding the derivative. The limit is h goes to 0 of 5x plus h minus 2x plus h squared minus 5x minus 2x squared all over h. So now if I want to FOIL all this out so that I can simplify things, I get 5x plus 5h minus 2x squared minus 4xh minus 2h squared plus 5x plus 2x squared all over h. And my 5x, this should be a minus. My 5x minus 5x cancels. My negative 2x squared positive 2x squared cancels. And in the numerator, I can see that I can take out an h. So this becomes the limit as h approaches 0 of h times 5 minus 4x minus 2h all over h. And now my h's can cancel. So this allows me to now evaluate the limit. It's the limit of 5 minus 4x minus 2h, which is going to give me 5 minus 4x. That again being my derivative function. So here, the first part of it, find the derivative. Now I want to find the derivative at this point, negative 1. That's going to be 5 minus 4 times negative 1, which is going to give me 5 plus 4, so 9. It's the second part of this. So I've found the slope of the tangent line. Now I want to write the equation of the line. So equations of a line going all the way back to chapter 1, that is y minus y1 equals m times x minus x1. Here, when we found f prime, that's finding m because it's the slope of a tangent line. It's the derivative. So this is really like m tangent, slope of a tangent line. And I want to write the equation of a tangent line, so great, that's what I have. I know that m is 9. Then I have x1 and y1 to substitute in. So this would be y plus 7 is equal to 9x plus 1. And we won't have you put it in y equals mx plus b form because you've already done so much. This is fine. This is the equation of the line that is tangent to this point on this equation. There's a lot that's packed into that. All right, we're going to do one more. Super fun. You're hanging on there. We have the limit as h approaches 0 of square root negative 2x plus h plus 1 minus square root negative 2x plus 1 all over h. So we're going to have to multiply by the conjugate in order to rationalize this. Square root negative 2x plus h plus 1 plus square root negative 2x plus 1 over the square root of negative 2x plus h plus 1 plus square root negative 2x plus 1. So this will become negative 2x plus h plus 1 minus negative 2x plus 1, and I'll just put parentheses around here for consistency's sake, over h times square root negative 2x plus h plus 1 plus square root negative 2x plus 1. In my numerator here, I get negative 2x minus 2h plus 1 plus 2x minus 1 over h times square root negative 2x plus h plus 1 plus square root negative 2x plus 1. 1 minus 1 cancels, 2x minus 2x cancels, h over h cancels. So this becomes the limit as h approaches 0 of negative 2 over square root negative 2x plus h plus 1 plus square root negative 2x plus 1. Now if I substitute 0 in, I would have square root negative 2x plus 1 plus square root negative 2x plus 1, which will give me 2 square root negative 2x plus 1. So I get negative 1 over square root negative 2x plus 1 as my derivative function. Now I want to know what is the derivative or what is the slope of a tangent line at the specific point negative 2. So I need to find f prime of negative 2, which will be negative 1 over the square root of negative 2 times negative 2 plus 1. So f prime of negative 2 is equal to negative 2 times negative 2 is 4, plus 1 gives me 5, so this is negative 1 over square root 5. That's not rationalized, but you're grown-ups, so I'm going to trust you to just leave it like this and sort of blindly accept that. At this point, you're doing so much work. Let's not worry about the rationalization. Let's just worry about doing all of this other crazy monstrosity. So this tells me that the slope at negative 2 is negative 1 over root 5, whatever that comes out to. Now I want the line, the equation of the line that's tangent. So y minus y1 equals m times x minus x1. I know that y1 is square root 5. Right up here, they gave me that. So I'll have y minus square root 5 is equal to m, which is negative 1 over square root 5. That's a terrible square root 5. Times x minus, or plus, sorry, 2, since this x value that they gave us was negative 2. And again, that's super messy. It's super ugly. It's not in y equals mx plus b form, but it is still an equation, or the equation, of the tangent line to that point. So I'm just going to be cool with you writing that. So again, a lot goes into these questions here, but the huge theme is to understand that when we're talking about the slope of a tangent line, we're talking about a derivative. And we're talking about a derivative, we're talking about the slope of the function at a given point. And then there's just all this like super easy work that goes into solving it.